Magic squares. 6 by 6 magic square. Input the values ranging from 1 to 36 in a 6 by 6 magic square such that the sum of rows, columns, and diagonals are equal. Solution. Since we're talking of 6 by 6, it means we're going to have a square array of 6 rows and 6 columns. So let us check the number of rows of this. We have row 1, row 2, row 3, row 4, row 5, row 6. And then the columns: column 1, column 2, column 3, column 4, column 5, column 6. Alright, so looking at these columns, the 6 by 6, I have divided the 6 by 6 into 4 parts, right? And considering each of the sections, the 4 sections, we could see that each of them is a 3 by 3. Okay, so this portion, the first one is gonna say, let's say, first part. Okay, this black, blue, and yellow, that 3 by 3 is gonna be the first, and then the green, red, and then this black, that one is gonna give us the second section, right? And the first, since it is, each of them is a 3 by 3, it is going to take n3s ranging from 1 to 9. Okay, the first one is going to take n3s ranging from 1 to 9, and the second section is going to take n3s ranging from 10 to 18, right? 10 to 18. And then we also have this section, which is also a 3 by 3, and this yellow and the green portion, that's going to be the third part, and it's going to range from it's going to range from 19 to 27, right? 27, since it's 3 by 3, 9 threes. And then the last one, which is the fourth, you're going to range from 28 to 31, 6, right? And as we have done in the previous videos, 3 by 3, we look at the extrapolation method as well as the rule of 45 degrees. So please, if you have little knowledge on that, you kindly watch the previous video before you get back to this one. So we're going to use the rule of 45 degrees to fill each of the 3 by 3 magic squares. Actually, it is 6 by 6 magic square, but I have divided it into 4 sections, and each of the sections comprised of 3 by 3, right? So the first one, the rule of 45 degrees, as we said, the first row, or the middle box, we're going to write out 1, 1 to 9, then 45, the rule of 45. We have an entry here, and you should take the last one, which is 2, then here 3, and then 4, then there's nothing here, 5, 6, this place we need to come down, 7, rule of 45, 8, and what, 9. Okay, then after that we come to this portion now, which is 10. We're going to start from here, right, in the middle, 10, then rule of 45, entry should come down 11. So rule of 45, enter here, then it goes here 12. There's enter here, so it comes down 13, here 14, 15. There's nothing, so it's gonna come down 16, goes here 17. Then we have our 18. Now the third one we have 19, so 19 is going to be in the middle. 19, so there's going to be an entry here 20. Then this entry rule of 45 goes here, that's 21. Here's fill, so we come down 22, and it's a diagonal, so 23 empty, 24. And there's no entry, comes down 25, then here 26, and let me write it to 26. There's going to be an entry here 27. Okay, then the last portion we have 28, right? 27, 28 is going to be in the middle of 28. So goes here, there's going to be an entry 29. Here 30. Then comes down 31, 32, 33. Comes down 34, 35, and 36. Okay. So now that we're done filling the entries of our 6x6 by splitting it to 3x3 and using the rule of 45 degrees to fill them, then there are few things that we're going to do in order to achieve the magic constant, right? So what we're going to do is that you'll be swapping some of the values. So actually the swapping is going to take only the first and the second. We're going to consider only the first and the second column, right? Now let me use probably a different color. Red would be good. So here, over here, see the 8, this 8, okay, this 8, the 8, and the 35. We're going to swap them. So what I'm going to do is that I'll bring the 35 here. It will be 35, and here will be 8. Okay, here will be 8. And then what I'm gonna do next is I will swap the 4 in the 31. This 4. So 4 and 31. So here's gonna be 4. Here's gonna be what? 31. Now the last swapping that we're going to do is this. The last swapping is going to be the 5 and the 32. 5. Let me change my color. Green, right? 5 and 32. I'm gonna swap them. So let me use red to right. So here will be 32, and here will be 5. Okay, 5. The 8. Let me write it to 8. Good. Let me 35 too. Now after this swapping, that's all we're done. we're done. And now we are going to check whether our magic constant is going to be true. What we're going to do is that we need to check that the summation of each of the rows should be the same. So we have the first row 35 plus 1 plus 6 plus 26 plus 19 plus 24. That's going to give us 111. And if you check all the rows, you're going to get the same thing. Now the columns, so let's check. Probably the first column we have 35 plus 3 plus 31 plus 8 plus 30 plus 4, and that one you're going to have 1 1 1. Steady, let me write it for steady, right? 3 0. Okay, right. And then probably let's check this. 19 plus 23 plus 27 plus 10 plus 14 plus 18. Yeah, that column 2 is true. Then the last thing we're going to check is our diagonals. Okay, so the diagonals too, we have 24 plus 23 plus 22 plus 33 plus 5 plus 4. And that's also going to give us 111. Then let's check the other diagonal. 35 plus 32 plus 2 plus 17 plus 14 plus 11, which is also 101. Then since we having the sum of each of the rows being equal to 101, the sum of each of the columns being equal to 101, and the sum of our diagonals equal to 101, it means that we're done, or we have achieved our magic constant to be 101. And that is all. We're done filling the 6 by 6 magic square with the values ranging from 1 to 36. If you find this video interesting, subscribe to the channel for more of such